Hi, Assalamualaikum. My name is Muhammad Syamil Nimbuddin and my metric number is 01DAD19F2031, and I would like to present a title Gideon pin or piston pin. And now I would like to tell the introduction. In internal combustion engine, the Gideon pin connects the piston to the connecting rod and provide a bearing for the connecting rod to pivot upon as the piston move. In very early engine design, including those driven by steam and many very large stationary or marine engines, the Gideon pin is located in a sliding crosshead that connects the piston via a rod. A Gideon is a pivot or journal. The origin of the word Gideon is the Middle English word goujon, which originated from the Middle French word goujon. Its first unknown use was in the 15th century. The Gideon pin is typically a forged short hollow rod made of a steel alloy of high strength and hardness that may be physically separated from both the connecting rod and piston or crosshead. The design of Gideon pin, especially in the case of small, high-revving automotive engine, is challenging. The Gideon pin has to operate under some of the highest temperatures experienced in the engine, with difficulty in lubrication due to its location, while remaining small and light so as to fit into the piston diameter and not unduly add to the reciprocating mass. The requirements for lightness and compactness demand a small diameter rod that is subject to heavy shear and bending loads, with some of the highest pressure loadings of any bearing in the whole engine. To overcome this problem, the material used to make the Gideon pin and the way it manufactured are amongst the most highly engineered of any mechanical component found in internal combustion engines. And now let's go to the next slide. Type of piston pin. Gideon pin use two broad design configuration. One semi-floating and second fully floating. Typical construction of Gideon pin or wrist pin is shown on the picture. That the design depends on technological and technical effectiveness. In semi-floating configuration, the pin is usually fixed relative to the piston by any interference with the journal in the piston. The connecting rod, small end bearing, thus acts as the bearing alone. In this configuration, only the small end bearing requires a bearing surface. If needed, it is provided by either electroplating the small end bearing journal with a suitable metal, or more usually by inserting a sleeve bearing or needle bearing into the eye of the small end, which has an interference fit with the aperture of the small end. During overhaul, it is usually possible to replace this bearing sleeve if it is badly worn. The reverse configuration facing the Gideon pin to the connecting rod of the piston is implemented using an interference fit with the small end eye instead. With the Gideon pin journals in the piston function of as bearing, this arrangement is usually more difficult to manufacture and service because two bearing surface or insert sleeve complicate this design. In addition, the pin must be precisely set so that the small end eye is central. Because of the thermal expansion consideration, this arrangement was more usual for single for single cylinder engines as opposed to multiple cylinder engine with long cylinder block and crankcase, until precision manufacturing became more commonplace. In the fully floating configuration, a bearing surface is created both between the small eye and gauge pin and the journal in the piston. The gauge pins are usually secured with clips. No interference fit is used in any instance, and the pin floats entirely on bearing surfaces. The average rubbing speed of each of the two bearings is half, and the load is shared across the bearing. That is usually about 3 times the length of the rod. The semi-floating design with an interference fit with the piston.
Thank you, Shamil, for your explanation. Now we go to the piston ring. The introduction. A piston ring is a metallic split ring that is attached to the outer diameter of a piston in an internal combustion engine or steam engine. The main function of piston ring is engine sealing the combustion chamber so that there is minimal loss of gas to the crankcase. Between the piston and cylinder, the piston ring is a part that is needed for an engine to work efficiently. So as we can see here, this is a piston ring types. Top ring, compression ring and oil ring control. A top compression ring. This is referred to as the upper compression ring. The upper compression ring is the piston ring that operates under the harshest condition with respect to thermal and mechanical loading. Its job is to form gas-tight barrier between the piston and the cylinder wall in order to seal the combustion chamber. Second compression ring. This is referred to as the lower compression ring. One of its job is to work together with the top ring in order to seal the combustion chamber. And last is oil ring. As its name, oil control ring implies, this ring scraps excess lubricating oil from the cylinder wall, maintaining proper lubrication while keeping oil consumption within proper limits. Construction of piston ring. Generally, the piston ring is cast individually. It is machined carefully so that it exerts uniform pressure against cylinder walls when in its position. A gap needs to be cut at the ends so that you can expand slip over piston head and release it while inserting it into the ring groove. Furthermore, the gap almost closes when the piston is inside the cylinder. Thus, the ring can exert pressure on the cylinder walls, which is a must for a better sealing. Besides, the end gap also ensures any circumference-wise expansion of the ring at higher operating temperatures. The piston ring always operates at temperature higher than the cylinder wall. Hence, the heat flows from the ring to the walls. Piston rings are made of special cast aluminium alloy or steel. Piston ring has a rib which named piston ring lock. It can be direct, oblique or step. The most common are piston ring with direct rib. The diameter of the piston ring in the usual state is larger than the internal diameter of the cylinder, so the ring input in the groove of piston and the diameter of the piston ring in the free state is larger than the internal diameter of the cylinder. So the input of the ring to the groove of piston do in compression state, and after decompression it fits snugly to the inside surface of the cylinder. So here is the diagram of the piston ring.
Okay. Thank you for Farhad. I will continue the presentation. My name is Muhammad Syamil bin Mustafa. My matric card number is 01 DAD 19F 1061. Okay, we're going to slide. Okay, A, cross-sectional space of compression, piston ring and how they work. 1.1 rectangular ring. 1.2 ring with a conical outer surface. 1.3 ring with chamfer on the inside. 1.4 ring with resected on the inside. You can see the example picture there. Okay, next slide. Okay, in this slide B, composite oil piston ring. One piston ring of this space, two axial dilator, three radial expander, one radial expander, four piston ring of this space, then piston ring lock. Okay, next slide. Okay, next slide. Engine piston heat with piston ring. One piston ring of this space, two axial dilator, five compression piston ring, six piston. Okay, D. Scheme of compression piston ring. Piston hole in the groove of oil piston ring. Cylinder oil piston ring slot in the ring and hole in the piston. Okay, next slide. Scheme of oil piston ring work. Piston, compression piston ring, cylinder, compression piston rings. Okay, next slide. Function of piston ring. The piston rings act to carry heat away from the hot piston into the coolant cylinder wall or block if of the engine. Heat energy flows from the piston groove into the piston ring and then into the cylinder wall, where it eventually will be transferred into the engine coolant. And piston rings have four main functions. The four main function will be continue. Ghana will be continue the presentation. Thank you.
Okay, thank you for Shami bro. Okay, my name is Ganagesar Anaki Mohan and my known metric is 01D81 and F2051. Okay, I will continue the next slide. Okay, the first seal for combustion gas. Okay, the first one is function is to fully maintain in cylinder ignites between the piston and cylinder wall. It works hard to keep a lid on combustion gas leaking into the gap between the piston and cylinder create at the time explosion. Okay, the third, if combustion gas leak, full power call to be realized and fuel combustion will increase, which is detrimental both economically and environmentally. Okay, second one is control lubricating oil, engine oil. Okay, first function to constantly create the minimum required lubricating oil layer to prevent burn. Inside an engine cylinder, the piston ring is subject to high temperature combustion gas, and with the piston must travel and return may thousands of times a minute or even to more to ensure the piston ring and cylinder to do not burn and to prevent excess lubricating oil getting inside the combustion chamber. The cylinder wall lubricating oil layer is controlled at minimum required. Okay, thirdly is heat conduction function. Okay, function that release heat from the piston to the cylinder. Okay, second, when the gas explode, the temperature inside the piston reach a heat approximately 300 degrees centigrade. If the heat remains inside the piston, the engine may be damaged. So that heat must be released from the entire the piston ring help to that. Okay, the last one is piston attitude support. Okay, first function that prevent the piston making strong contact with the cylinder wall. The second is if the piston is an angle, as it moves it makes contact with various places and this can cause engine damage. The piston ring support the piston so the piston can travel smoothly up and down. Okay, number 3, operation of piston rings. Okay, piston rings seal the combustion chamber, conduct heat from the piston to cylinder wall, and return oil to the crankshaft. Okay, combustion gas pressure force the piston ring against the cylinder wall to form a seal, and pressure applied to the piston ring is approximately and proportional to the combustion gas pressure. Thank you.